Okay, we're going to go ahead and take a look at example number 2 together. It says, a new container design has been adopted by a manufacturer, and the company wishes to know if the color of container matters. Color preferences indicated in a sample of 150 individuals are as follows. We have the data listed there for red, blue, and green. Test using an alpha level of zero point 0.1 to see if the color of container matters. Okay, so for our null hypothesis, we could word this the same way we did the last one, equal frequency for the ho and unequal frequency for the ha. They use the word color preference. So if we do have equal frequency, that would mean that there's no preference. If each color occurred the same amount of times, it would mean the same as no preference. So again, you have choice in how you word those, as long as it means the same as equal frequency for the null hypothesis. The alternative hypothesis would be that there is a preference. Or in other words, these colors do not occur with equal frequency. Okay, so that's step number 1 of our process. Step number 2, we're going to find the critical value. Here's my chi-square distribution. We shade that right tail, again indicating that if there is a preference, the observed is going to vary from the expected a large amount. The alpha value given in the prompt was 0.1. I am going to remind you guys that if the alpha value is not given, 0.05 is the most commonly used alpha. Okay, but our alpha value for this example is 0.1. Degree of freedom, we have 3 colors. So there's 3 categories there. 3 minus 1 gives us a degree of freedom of 2. So let's go to our chi-squared chart and look up that critical value. So for 2 degrees of freedom, an alpha level of 0.1, I see 4.605 as that critical value. 4.605. Okay, so that's where the critical region starts. That's our critical value. Again, I'm going to go ahead and erase that. And going on with step number 3, we have to find, again, the test statistic. So we have the observed values listed. These are observed. We have to figure out what's the expected. It did tell me that the sample was 150 individuals. So if I add up these 3 numbers, I should get 150. So I'm just going to take that 150 and split it evenly between the 3 categories. So my expected value would be 50 for each color. All right. The chi-squared test statistic, we take the first observed value minus the expected value, square that, and divide by the expected. I would do that for blue, observed minus expected squared over expected. And again for green, observed minus expected squared divided by expected. I'm going to go to the calculator, guys, to figure out what that sum is. So again, we're going to enter the data into our menu. So make sure that you are entering the observed values in list 1 and the expected values in list 2. Okay, I went ahead and entered those observed in list 1 and the expected in list 2. I'm going to go to stat, over to tests, and I'm looking for the chi-squared GOF test. Again, option D in my calculator. I've entered the observed values in list 1 and the expected values in list 2, but for this prompt, I had a degree of freedom of 2. Calculating, we get a chi-squared test statistic component of 6.24. Step number 4 is the p-value. I get a p-value of 0.044. 0.044 is lower than the alpha level of 0.1 in the prompt. When P is low, we reject the hoe. So we're rejecting the null hypothesis. That null hypothesis was that there was no preference. We're rejecting that. So there does seem to be a preference of color. So I guess, did we see if the color of the container mattered? Yes, it does seem to matter at alpha equal to 0.10. Okay, here's the you try example. Pause the video here, guys. See if you can complete the 6 steps to hypothesis testing for goodness of fit, and then unpause the video to see the answer. Okay, guys, here are the results of this last test. Again, the ho and ha were the same as the last 2 examples. The critical value, I did use an alpha of 0.05 since it wasn't stated in the prompt. Degree of freedom of 6, that gives me a critical value of 12.592 from the chart. For step number 3, I just showed how we would use the formula for the days of the week, Sunday and Saturday. So the first and the last with plus dot 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 in the middle. I used the calculator to find that test statistic of 4.5, the p-value of 0.609. P is greater than alpha. When P is not low, we do not reject the hoe. And so at alpha equal to 0.05, there seems to be equal frequency among days of the week that students do homework. Also, one last thing, guys, to find that expected value for this prompt, if we add up all of those numbers in the chart, it equals 56. It also told us that in the prompt, 56 students. We're dividing that by the 7 days of the week, which gives me an expected value of 8. So in my list 1, I put in all of those numbers, the observed values, and in list 2, I put 8 for every single expected value in the list. Okay, guys, post any questions that you have in the discussion board.